Welcome back, everybody, to another exciting lesson about polynomials. We are going to talk about factoring polynomials, a little bit more factoring from what we did last time. So we're going to be talking about factoring by grouping and then sum and difference of cubes. So first off, factoring by grouping. If we have an expression like this, 4 terms, sometimes we can factor this by grouping. What does that mean? Well, what we do is we group the terms into 2 pairs, here and here. And we try to think of the biggest term or the greatest common factor we can divide out of each pair. So the biggest thing I can take out of x to the third and 7x to the second, well, there's no number that goes into both of those other than 1. But I can take out 2 x's, right? This has a total of 3 x's being multiplied in that term, 2 x's. So I can take out or divide out 2 x's. And what am I left with? Well, x squared times what is x to the third? X. X squared times what is negative 7x squared? Negative 7. I do the same thing here. What can I take out of 2x and negative 14? Well, 2 is common to both and no x's. So let me try to take out a positive 2. Sometimes we have to tweak that a little bit and change the sign, but let's see if this works. 2 times what is 2x? X. 2 times what is negative 14? Negative 7. Or in other words, negative 14 divided by 2 is negative 7. You'll notice that we have the same factor here and here, x minus 7. What we can do is we can think of this is one big term, and this is one big term, and now we're going to factor out an x minus 7 out of each of those terms. So what does that look like? Well, I'm going to have an x minus 7 out front, and then what am I left with? What do I have to multiply x minus 7 by to get this? What's missing? Well, x squared is missing, so I need that. What do I need to multiply x minus 7 to get this? Well, what's missing? 2. So I have plus 2. So there we go. That is factored. Okay? Let me do another one. So here, again, we pair them. If you don't like to draw little curly brackets, you can go underline style. And we need to figure out the biggest thing I can take out of these two. Well, it'll be x squared is common to both. Right? 2 x's are contained within each term. So x squared times what is x to the third? X. X squared times what is x squared? That would just be 1. Here, what's common to both of these? Well, 1 or negative 1. I'm thinking that since they're both negative, I'm going to take out a negative 1. Negative 1 times what would be negative x? Well, that would just be x. Negative 1 times what would be negative 1? That would be positive 1. Now, if you had taken out a positive 1 out of both these, you would notice at this point, this would be a little different. And then you'd have to go back and try taking out a negative 1. Because I noticed I did it the correct way because these match. All right. Now, this is not always going to happen with every 4-term polynomial. This is actually kind of a rare thing, but it is going to come up a little bit in the polynomial unit. So yeah, these have to match in order for this method to work. Okay, now we're going to take out x plus 1 out of both of these bigger terms. This is one big term here. This is one big term here. So I'm going to take out x plus 1, and what am I left with here? X plus 1 times what would be this term? X squared. X plus 1, as a whole thing, as one unit, times what would be negative 1 times x plus 1? Well, negative 1. So there we go. Now this one I can actually factor further if you hopefully recognize this as a difference of squares. So that can factor further. I'm going to just bring down the x plus 1. This factors into, remember this from last time, the square root of x squared equals x, square root of 1 equals 1. So I can rewrite this part here as x plus 1, x minus 1. And last but not least, these are the same factor, so you can rewrite that as x plus 1 squared, because if you have 2 of them being multiplied. And there we go. That is totally factored. All right, go ahead and pause and do the your turn. All right, here's what I got for the your turn. I was able to take x squared out of both these, ended up with this. 5 out of both of these, got this. And then the x minus 3 comes out of both of those, and we end up with this as our answer. All right, on the sum and difference of cubes. These you can think of as formulas. So a sum of cubes, well, that would be something cubed plus something cubed. And here's the formula. We just have to figure out what's A and what's B, and then we can just sort of plug in our A and B. Same thing for a difference of cubes. We've seen a difference of squares before. That can also be thought of as a formula. A squared minus B squared equals A plus B times A minus B. We've done that before. I didn't really teach it as a formula, but we're going to think of these as formulas. It ends up being a little bit easier. All right, so here, let me just label that so we get mixed up here. Okay, now let's go ahead and factor this. We need to figure out what is A and what is B. Well, let's see. A would basically be the cube root of this. Now, I know you haven't done a lot of cube rooting here, but we need to figure out the number multiplied by itself. Well, really, the expression that multiplied by itself a total of 3 times is 125x to the third. So what we're doing is this, and you've probably seen cube root once. It comes up, I know, one place in geometry. So we're going to cube root. On your calculator, what you could put in to figure out the cube root of 125, it's hard to find on most calculators how to put in like a different number root other than a square root. I'm going to show you a quicker way to do it. If on your calculator you go 125, and that depends on the calculator, but some of them use the little caret symbol, and then you put in 1/3. Something to the 1/3 power is the same as the cube root. So that'll come out to 5. Okay, so this actually ends up being 5, and then what multiplied by itself a total of 3 times is x cubed? Well, that would be x. So the cube root of this first term is 5x. And then what's the cube root of 27? Again, you could do this thing in your calculator, 27 to the 1/3 power. Some of you might already know the cube root. It's 3. And then, so that's our A and that's our B. And now we just plug this into, this was a difference of cubes, so we have to use that formula here. So let me write out the right-hand side of that formula. So A minus B times A squared plus AB plus B squared. Now we just have to plug in my A and B. A is 5x, B is 3. So I'm going to have 5x, because that's what A is, and B is 3. A squared, now careful when you do this, you're going to have to go 5x squared, like that. Not just, you got to use the parentheses, and we'll get back to that in a minute. Okay, and then you're going to have A times B. Well, A times B is going to be 15x. I'm going to go ahead and just do that in my head. And then we also have B squared. Well, B squared is 3 squared, which is 9. Okay. What this becomes, well, it's going to be 5 squared times x squared. It's like you can kind of distribute that exponent. You probably did that with exponent rules at some point. But yeah, you get 5 squared times x squared, which that's just going to be 25x squared. And now we have this, and of course bring down the 5x minus 3. So that is the factored expression of this. By the way, some people look at this and they think, oh, can I factor that further? No, you never can. And I'm being serious, you never can factor that. It's never a factorable expression here. Okay, let me do one more example, and then I'll let you guys do the your turns. So this one you might say, this is not a difference of cubes. I see to the 4th power. Is this it's not a sum of cubes. Is this like, a sum of something to the 4th power? No, this is possibly a sum of cubes. We first need to factor out a common term. And in fact, I should have been doing that all along. You always should check for that first. Is there a common term? And yes, there's a common term here. 5 goes into both these, and so does x. So we're going to divide out 5x, kind of like we did before in the factor by grouping. 5 times 8 is 40, and then I need 3 more x's, right? So an x to the third. X times x to the third would be x to the fourth. And then 5x times 1 is 5x. Okay, this is a sum of cubes. 8 is a cube, 1 is a cube. I didn't point this out earlier, but these are some common perfect cubes. These are the lowest perfect cubes. 1, 8, 27. This is like, 1 cubed, 2 cubed, 3 cubed, etc. Okay? So it's good to be able to recognize at least some of these. I don't expect you to have them memorized, really beyond this. This is 6 cubed right here. All right, now we think about what our a and b are. Well, a would be the cube root of 8x to the third. Again, you can put in your calculator 8 to the 1/3 power. You didn't really need the parentheses around this number like I did up here. I don't know why I did that. But you do need the parentheses around this for sure. Okay, so you get 2. So this comes out to 2, and then what multiplied by itself 3 times is x cubed? Well, x. So 2x is a. B is the cube root of 1, which is just 1. All right, there's my a, there's my b. Now you just plug these into the formula. This time we have to use the other formula. This is a sum of cubes. So a plus b times a squared minus a times b plus b squared. So a is 2x, b is 1. This time I'm going to do this one in my head a little bit more rather than write it out like I did here. So a squared, again, this is like 2x times 2x. That's going to be 4x squared, not 2x squared. You're squaring both of these, right, the whole thing. And then minus a times b, well, so a times b is 2x, so minus 2x. And then b squared, well, that's just going to be 1 squared, which is 1. So there we go. There is my factored expression. You guys do the your turns. And we're back. The your turn answer I got was 3x plus 4 times 9x squared minus 12x plus 16. Yeah, so a was 3x, b was 4. Plug them in. Okay, don't forget on this here, you squaring this whole thing. 3x times 3x is 9x squared. All right, and then down here, you did have to factor out a 3x first. And so I ended up with this. And then you take the cube root of each of those, right? And so I got 2x is my a, 3 is my b. Oh, yeah, make sure you use the right formula in this one also. This was a sum of cubes, so make sure you use that formula. This was a difference of cubes, minus here, right? So you had to use that formula. Okay, so 2x minus 3, and then times 4x squared plus 6x plus 9.